Hello, linear algebra student. This video is for chapter 1.10. We're going to use systems of equation to solve, to model some problems in science and engineering and business. But this particular one, we want to particularly look at application to resistor network. If you are going to take physics later on, you will run into this problem. And this would be solved by systems of equation that you have learned here. So let's look at this resistor network diagram. So it could be as simple as that, just a cell, a battery, and then connects to some resistor, or complicated as like parallel resistor, or even like networked that way. So we're going to look at how to solve the current that's flowing through them. So first of all, look at the diagram, the notation first. So the jagged line, like wiggly line, denote resistor. And the number next to them give the resistance written in ohms. And then there is a voltage source, which is usually a battery or whatever voltage that would cause the current to flow. And the way the current flow is from the shorter line towards the longer, as indicated. Well, there is no arrow here, but basically you would imagine the flow being like this. This is the shorter one, right? Okay, let's me do it. This is the shorter one, so the voltage would go this way. Okay, from this one flow this cause the current to flow in this direction. And then the current is labeled as IK, and current flow in like a circle. Okay. In the and then for current, like in this one, usually they are indicates to flow in the counterclockwise direction. If they're flowing in the clockwise direction, then the current will be negative. Okay. So the Kirchhoff rule that's model this the behavior of current and voltage is the sum of resistance times I. So R times I in the counterclockwise direction around a loop equal to the sum of voltage sources in the same direction around the loop. So if there's that many voltage sources, our V should be the same. Okay, so we can look at each branch and then just calculate R times I, right? R times I, and then have it equal to the voltage. So you see how the voltage flow from this to this. Okay, that's that. If that is the case, you can see that this voltage has a positive direction. Is positive because it followed the same as the counterclockwise direction that we have assumed. Okay, so to do that, we can start off with this side first. This side has no current, so it's 0, and this side has 2, so we would say 2I1, and then this is 4I1, and then after this, you just follow the flow, okay? And then this is 2I1. Usually I start from here, but you can start from here. 2I1. And then it fall back here to the beginning, and that is equal to the same direction, 18. So this is our equation, and then if we add them together, that would be 8I1 equal to 18. So I1 is equal to 18 over 8 or 9 over 4. Or if you round it, it's 2.25 amp current. So there's a current of 2.25 amp flowing in this direction to drive the 18 volts. Right. So that's how you solve it. So what about if we have complicated network that's interconnected circuit diagram like this? So we do the same thing, except we would keep this as the I1 loop here, and we'll just go through the 3 loop. Okay, we have 3 unknown, we have 3 loop. So the first one, number 1. So I start from here. So this is I1 and it is in this direction. So 4I1 plus. So basically is Ri, right? R times I. So these are all R times I. Plus, this is here. Now this is more complicated. You can't just say that it's 3I1 because it is also connected to the other side, but in the other side, when it is flowing in this direction, R2 is in this direction. This is R2, right? But then this is R1. So if I follow the counterclockwise direction for R1, it is positive. So I say 3I1 minus I2 because they are competing. This I1 and I2 competing, but they all go through the resistor 3, right? And so it's just that whenever you are touching a branch that has two current flowing, and if they are different direction, you just say that resistor number ohm multiplied by the resulting current. Plus, and then we have 4. So 4I1. And then there's nothing, right? There's nothing here. But it is equal to, what is this direction? This direction is 30. It's positive 30. So that's number 1. What about number 2? The second loop. So I'll start off from here is 1I2, right? There's nothing. This is just a line. And then this one will have I2 minus I3. Do you agree? This is I2, but I3 is going counterclockwise. So, and this at this branch is opposite to I2. And the ohm value is, the resistor value is 1. So I'll say 1. We don't look at the volts. The volts is valid for the loop only. Okay. So 1 times what? 1 times I2 minus I3 plus this one is just 1 I2 and then add 3. Now in this case, my I2 is positive, relatively speaking, but I1 is against it, right? There I have. Okay, I'm done. So, and then what about this? Is this in the counterclockwise direction from the short line to the highlight? Yes, that's right. So it is equal to 5. And then the third one would be what? Let's look at this one first. 1I3 plus this line doesn't have anything, has no resistor. This is 1 also. 1I3. And this also have 1, but it is I3 minus I2. 1 I3 minus I2. Because from I3 point of view, I3 is positive, but I2 is negative. And then resulting is what? What is the result? So this would be flowing backward, right? And then this one is also flowing backward. So you flow back negative 25. Okay, so that's the 3 equation that you have. So I'm going to simplify all the I1, I2, I3 into a equation. So the first one will be 4I1, 3I1, and 4I1. So that is 11I1, right? 11I1 and then minus 3I2 is equal to 30. The second, do I have I1? Oh, I have 3I1, right? I have 3I1 over here. So I would say, oops, 3I1. And then how many I2 do I have? A lot. 1, 2, 3, 6 plus 6I2. And then there is 1I3. And it's equal to 5. The third one would be how many I1? I don't have any I1, but I have a negative I2. And then all these 3 of them, is it 3? 1, 2, 3 plus 3I3 is equal to negative 25. So this become solving an augmented matrix. 11, negative 3, 0, 30. 3, 6, negative 1, 5, 0, negative 1, 3, negative 25. Right, so I was going to do a matrix calculator. So 11, -3, -3, 0, 30, -3, -6, -1, 5. Is that what it is? Let me take a look. Right, and then 0, -1, 3, 35, -25. Right, so that would be 35, -25, 0, 1, -3. So, and I do a reduce row echelon for B. Oops, no, lowercase, should be uppercase. So you can see that it is, let me put it over. So 10003, 010, 1003, 0101, 001, -8. So I1 is 3 m, I2 is 1 m, and I4 is I3 is -8 m. -8 m just means that it's flowing not in the counterclockwise direction, but in the clockwise direction. Okay. Well, it has to do because the batteries are connected that way. Okay, so we have another one here. So I'm going to do it in the next video because I don't think I can finish it in 5 minutes.